Got another harder titration calculation for you. This one's the fourth one that I've done. So as the question, if you want to have a go at that, just pause the video and then play on when you're ready for the answers. So like I always do, got a little diagram here which sort of lays out this information sort of in picture form, just hopefully makes it a little bit easier to process the information in the question. So they've taken 1.2 grams of silicon tetrachloride, dissolved it in water. That reaction's taken place and you can see there it generates hydrochloric acid. So that's then poured into the volumetric flask, 250 cm cubed, made up to the mark, and then 25 cm cubed of this solution is titrated against sodium hydroxide with that concentration, and that was the mean titer. So the titration reaction is between sodium hydroxide and the hydrochloric acid that was generated up here. And then obviously we've got to work backwards to get the percentage purity of the silicon tetrachloride in this original sample. Okay, so the first thing I'm going to do is work out the moles of sodium hydroxide used in the titration. So moles is concentration times volume. Remember, that's got to be in decimeters cubed. So 0.00187 moles of sodium hydroxide were used in the titration. The moles of hydrochloric acid that must have been in there will be the same because sodium hydroxide and hydrochloric acid react in a 1-to-1 ratio. Okay, so now we know the moles of hydrochloric acid that were in the conical flask. We can just scale up, multiply by 10 to find out how many moles of hydrochloric acid must have been in this flask here. Okay, so now we know the moles of hydrochloric acid that were in there. Remember, they were generated by this reaction here. So the moles of silicon tetrachloride that must have been present to generate these moles is going to be 1/4 of the moles of hydrochloric acid. So the ratio is 4-to-1. Okay, so that's coming out at a moles of SiCl4 in that original 1.2 gram sample of 0.004675. So all we need to do now is work out how many grams of SiCl4 must have been present by multiplying the moles by the MR of SiCl4. And that's coming out at 0.795 ... So the calculator value is still stored in the calculator. So all I need to do now is to work out the percentage purity or the percentage by mass of the SiCl4 in the sample is just put that mass of SiCl4 over the mass of the sample and multiply by 100, which gives me a percentage purity of SiCl4 in the sample of 66.3%. to 3 significant figures.